What's up, guys? We are in the second part of the video series, and last video we have discussed the basics machine learning methodologies. There we have discussed about the three main categories of the machine learning, that is supervised learning and unsupervised and reinforcement learning. Okay, today in this video we are going to discuss what are the one of the supervised learning methodology and supervised learning algorithm that is called as the linear regression. Okay, in this slide you can understand how is the classification of those supervised learning, unsupervised learning, and the reinforcement learning are going on. According to that, linear regression, logistic regression, support vector machine, KNN, and the neural networks are coming under the supervised learning, and the unsupervised learning, K-means, C-means, HCA, and the a priori algorithms are coming under the unsupervised learning. There are more things will be available there, but when the time goes, we will be understanding what are those unsupervised other algorithms. And under the reinforcement learning, we are discussing about the cube learning and SASA, right? These are the things what we are going to discuss. So we will be discussing in this video what is called the linear regression. And guys, you have to understand, because the now this is a 3 days special challenge workshop. Okay, so I think you guys are still waking up and awaiting until this video is releasing. And I want to explain you, without understanding the machine learning theory, you cannot develop what we call the system. Okay, you can go to the Kaggle or any other data sets available websites and download the code and do the things, but it is not the real way of learning machine learning. Okay, if you download the what we call, if you download the code and if you import it to your what we call code editor, and you are doing something, or if you are just following a YouTube video and you are copying the same thing, means you are not learning that one. But you have to do something by your own. You have to learn the theoretical aspects properly, then only you can do the practical aspects. That's why I am taking these first few videos in order to explain you the theory behind these data science application development properly. So after getting these concepts properly, you can straight away go to the coding part, and you can do the coding. Okay, right. To do the coding, you want to understand the Python basics. So I will be explaining those things also there. Okay, one separate video, I will be explaining all the necessary Python fundamentals for our data science project. So, right. Now, I told you about the our first focus is to develop price price estimation project. Okay, price estimation project. That means a real estate project. They are going to think about what we call the price estimation. Actually, it is the one. It is the project that I am going to explain here. Okay. I don't know whether I have explained it or not, but that is the project I am going to explain. As the first project I am going to explain, it is under the supervised learning. Okay, it is under the supervised learning. Okay, and it is under the regression. Okay, in order to understand about the regressions, first of all, we will understand about the linear regression. Linear regression. Okay, so I will be going like this way, because these slides I have to give the credibility to Mr. Murtaza. Okay, so I'm getting those resources from Mr. Murtaza. So the whole credibility should be going to Mr. Murtaza, right? Then what we call if we try to understand about what is this linear regression, we have to first understand about what is called the generalization. Generalization, as an example, if you understand about that this type of milligram, if you available in your blood, that means you have the tendency to you have got attack to diabetics if you have this one. And if you are raising a heavy object, means you are getting more pain, and also that is also a generalization. And if you hit the what we call the like button here, that means you are touching the YouTube algorithm. That is also a generalization. Okay, so guys, I think you have to touch the what we call like button, then only this will be going to more people. Okay, right? That is also a generalization, right? What we call then these generalization principles. Okay, these generalization principles we can easily understand by what the equations. Okay, the mathematically we can understand these generalization concepts by using the equations. If you are using this type of equation, F equals ma or any other equation, what we are getting when you are going to mathematically interpret those things, you are getting equation. Okay, one of those equations we can generalizedly we can explain those equations as polynomial equations. Okay, as a generalization, we can say those all of those mathematical equations are coming under the polynomial equations. All the mathematical equations are coming under polynomial equations. Okay, if equals ma or any other representation will be coming under polynomial equation. Poly actually means many. Nomial means terms, many terms. Okay, many terms. Okay, then these are the things normally, generally we can consider as the polynomial equation. One thing is the linear equation. You know about y equals mx plus c. It is a linear equation. And if you get a curve like this way, we can say it is a quadratic equation. The normal general way of representing quadratic equation is y equals ax squared plus bx plus c. And if you get like this type of curve, okay, this is only 1 point curve, and this is 2 point. So this type of thing we can consider as a cubic curve. Okay, their equation is y equals ax cubed plus bx squared plus cx plus d. Okay, if you see the degree of this one, degree means the highest value of the x, highest power of the x. It is here 1, and here 2, and here 3. And we can say there is no curve here. It is just a linear one. And here only one curve. Quadratic means only one curve. And cubic means it has two curves, two types of shapes in the curve. So we can say it is two curves. And see this one, this has only one, this doesn't have curves, and it touches only 1 point in the x-axis. In the x-axis, it touches only 1 point, and this curve, it touches at 2 points. The x-axis, it touches 2 points at the x-axis, and this one, the cubic curve, it touches 3 points the x-axis. Okay, then this is 1 point, and this is 2 points, and this is 3 points. You can easily see those things. Okay, why I'm explaining those things? Okay, what is the reason behind that one to explain about these curves? Okay, see, in the if we are getting this type of plot, okay, when we are getting this type of plot, okay, from our model, okay, we have to identify what is that one. What is that? What is the interpretation of that? This is, we can say, these all those points are scattered along one line, one straight line. Okay, it will be like this way. It will be like this way. The points are scattered, but it is all those points are towards one straight line. So we can say it as a linear one. This is a linear one. We can say it is a linear one. What you can say about this? By seeing this one, you can say it as it is a curve. It is a curve which touches only one point the x-axis. Okay, sorry, it touches 2 points the x-axis. Okay, if you take x-axis or any line which is parallel to the x-axis, you can say that it touches 2 points the x-axis. You can easily see this one like this way. Okay, 2 points touches or cuts which is parallel to the x-axis. What can you say about this type of scattering? You can say it is two-way curve, two shapes, so it will possess 3 points. So it will be like this way. Okay, it will be like this way. If you draw a parallel line to the x-axis, it will possess 3 points. Okay, so this is a cubic curve. By understanding the scatter, according to the model that we are using, if we are getting like this type of we can say it is a cubic curve. Okay, right. Now we'll come to this one. Okay, I will explain why we have explained these type of curves. What is the reason behind these things? Okay, try to understand that one. Okay, suppose now we want to build a model to estimate the price of a house according to the size of. Okay, we want to estimate the price of the house. We want to estimate the size price of a house according to the size or respect to the size. Okay. Okay. Then only one. Then we can say there are two variables available. One thing is the size, and the other thing is the price. One of those things we have to consider as the independent variable. Independent variable means the variable which is varied, and the other thing will be the dependent variable. Okay, according to this size and price, what is the thing which will be varied? Okay, now customers are coming and they will be requesting the different types of sizes. According to those sizes, our price will be changed. Now the customer is going to change the size. Therefore, size is our independent variable. It can take any value. According to that, our the estimated price will be changed. So the price will be the dependent variable. So you will be getting this type of sample data set. Okay, size according to size, price will be 80 lakhs. Okay, 1,400 square feet, it will be 90 lakhs. 2,300, it is like 110 lakhs. Like that way, it will be varied. This is a sample data set. Size and the price. Size and the price. Okay, then by considering those values, what you can say, we can consider about our houses. Okay, our houses like this way according to the size. Like when the square feet is 1,200, it will be like this. If it is 1,400, it will be like this. The price will be increased. Here is the size. Okay, now it is the 2,300, it will be like this way. So by using this, our model will plot a graph like this way. By using that plotted graph, we can what we call our model will give us a result. Okay, it will be telling now. Suppose now a customer is requesting like I want to have a 3,200 square feet of house. Okay, according to that, it will determine what is the price of this one. Okay, by using this model, it will be determined what is the price of that one. Okay. Okay. Then what you want to do here now, by considering those houses, you can plot a graph like this. it will be very much similar to a linear graph. Okay, it will be like this way. The graph, even though it is going like this way and zigzag way, you can find out the best fit graph. Okay, you can find out a straight line, linear line, straight line across that graph. Okay, but our model has to get the best fit line. Best fit line means what is the most suitable graph, which minimize the errors. Okay, now you can understand this actual graph is not a straight line. Okay, it has some points which are moving away from the what we call straight line behavior. Now this uh, this is not the actual place, but graph is going like this way. But you have to make it very much close to a straight line. Then only we can consider it as a best fit line. How do you do like this way? Okay. So the concept is the linear regression. What do you mean by the now linear means it is a linear means that it is a straight line. What do you mean by the regression? Regression means you are minimizing the error. You are minimizing the error. Okay, regression means what? You are minimizing the error. Now, suppose now these are the scattered points. Okay, this is your linear one. But you know that these points are going away from the straight line. That means there is an error. Okay, if you are minimizing this error and getting close to this straight line behavior, we call that type of model as the linear regression. That thing we are calling as the linear regression. That means you are getting the best fit line. We can consider it as the linear regression. Okay. So in the linear regression, what you are getting a straight line y equals mx plus c. And according to the gradient and according to the intercept, what will happen? Your model value will be getting closer to the what we call getting closer to the best fit line. Okay. So if you consider about the graph that you have got, okay, there will be now the predicted value is a straight line. The predicted value is what you are predicting is what straight line. But what you are actually getting is like this type of way, because according to the data set, what you are actually getting, according to the data set, what you are getting like this type of zigzag way. But the model is predicting is for it is a straight line behavior. Okay, that means there is an error. Okay, so now what is the error? Error means predicted value minus the original value. What is the error? Error you have to define. Error equals predicted value minus original value. Then what is this total error? Total error means you have to add off all of these errors. Here, you know that predicted value is here, error is somewhere here. Now there is a difference, there is a difference, there is a difference. Like that way, you have to add all those errors. One thing, are you actually getting total error by adding those things? Suppose now here now, if you take this part as positive, what you can say about here? It is now below the straight line. Now here above the straight line. Now if you consider this one as positive, this will be negative. And positive and negative are getting cancelled. Then you are getting a zero value. So are you actually getting a zero value as the error? The error cannot be zero. When there is an error, you can't say that error is getting cancelled and it is getting zero. If there is an error, the error should be exist. Okay. What you can do, you can minimize the error. You can't get the error as zero. So getting the error as the total error by adding all of those errors is not a good idea. Okay. If you are getting the error as error 1 plus error 2 plus error 3 like that way, if you are getting the total by adding the thing, it is not the good way of getting the error. I have already told that error means the predicted value minus the original value. Predicted value means the value which is exist in the straight line. Original value means the according to the data set, what you are getting is the original value. Now there is a difference, predicted minus the original, that is called the error. But now there are several points, and according to that, we can calculate the total error. But when you are getting the total error, some points are below the line and some points are above the line. So those things are getting cancelled and you will be getting a null value or the zero value. But actually you cannot get the error as zero since there is an error exists. Okay, so you can't just you can't just add the errors and get the total error. Then what you are getting? So this now the below points and the above points are getting cancelled. So in order to avoid that one, what you can do, you can square the things. Okay, you can square the thing. If you square a negative value, it will be always a positive value. Okay, like that way you can square the error and add the things. What will happen? Now, this is explained what will happen. Now, in these 2 points, if you consider this error as 60 and this error as minus 60, this is getting cancelled and the answer will be 0. Okay, but actually error is available. You can't say that it is 0. Okay, so to minimize that one, what you can do, you can square the things. You can square the thing. Now this 60 becomes 60 square. And this minus 60 also, minus 60 square means it is a positive value. So you are getting an error. But since you are squaring and adding the things, what you are getting a big value. Okay, you are getting a big value. Okay, like this way. Now, if there are more points available, what you are getting a very big value. Okay, 60 squared, like that way you are getting the values. You are getting a very big value. So how do you reduce this one? Okay, how do you reduce this one? You can get the mean value of the squares. Okay, mean square error. We are calling this thing as a mean square. If there are 8 points, what you can do? Square all of those errors and add those things and get the mean value. What you are doing? You can square all of those errors. You can first square all of those errors and then add all of those errors, then get the mean value. Then divide by the number of points, then you are getting the mean squared error. Okay, what you have to do, these error points. Now, suppose it is 60 and it is minus 60, like that way there are 8 points are available. Get all of those errors and square those things and divide by the number of points. Here it is 8, and you are getting the value as the mean squared error. Okay, that is a good way of getting the error. Okay, then according to that, you can say what is the predicted value and what is the original value. Okay, now if the predicted value is 140 and the original value is 120. Okay, first of all, you can get the error. Predicted minus the original. 140 minus 120 is 20. 20 squared is the first error. Here the error is, then 20 squared is 400. Like that, the other points also you take the error and square it. Then add all of those things. Then what you want to do, you have to divide it by the number of points. Then you are getting the mean square error. Right? You are getting the value as a mean square. Now, then according to the mean square error, after getting the mean square error, now your what we call machine learning model, okay, it tries to represents the what we call the predicted value, okay, predicted value with the mean square error. It will be now after taking this predicted value, it will check with the mean square error. Now suppose this mean square error is 1000. Okay, now mean square error is 1000. Then it is trying to minimize the error. Okay, then we'll see another line. Now this is 1000. Okay, this is 1000. 1000 value, and suppose now it will be a little bit slow down. Okay, the model will be checking. Model will be checking its predicted value, and it will be checking it with the error. Okay, mean square error. Now it is 750. 750 is slightly less than 1000. Now that means it is a now it is closer to the what we call the reality. Then again now check with the error and the line. It tries whether it can minimize error more. Okay, then if it suppose it is the mean square is 438, again check. Okay, what is the what will be the whether it can reduce the error like that way. Check. Then like if it is 327, you can say down this will be a little bit closer. And after that, if it is like 170, okay, the straight line and the original value. And if it like the very best way, if it is getting some particular point, it will be taken considering as the best fit line. Okay, then we will be getting the this if we reach to this position, okay, machine learning model, it will be understanding where it cannot reduce up to that point. Now this will be the best fit value, and according to that, it can predict the price of the house. Okay. Now here we have considered only one variable. That means the independent variable has only one value. That is the size of the house. Okay. According to that, then we can predict the value of the house. Okay. Now it is a straight line. Now it is very much close to a straight line. Okay. Now it is suitable to use this type of equation, y equals this type of thing, because now it is closer to a straight line. Since it is close to a straight line only, we can use this one. Then the size of the if we input the size of the house, okay, size of the house, then we can predict the according to the model, we can predict the price of the house. If we input the size of the house, we can predict the price of the house. You can see that this is a label data, because we know the input and we know what is coming as the output. Okay, so this thing can be considered the supervised model. And here in the supervised model, under the supervised model, we are discussing about the linear regression. Okay, now what will happen now? Then generally we are not dealing with only one independent variable, not only size. Perhaps it will be number of bedrooms and number of bathrooms. According to that only we have to estimate the size of the house. Now in the linear regression model, you can keep only one variable. But if you want to have many variables, you have to have multiple regression model. If you want to have multiple independent variables, then you want to have multiple regression model. Now the thing is, it will be difficult to plot what we call the graphical way to interpret the multiple regression model, because if there are more variables, it will be difficult to what we call plot it. But you can understand it like this way. If it is a linear regression model, only one variable is available. It is like y equals mx plus c. But if there are more variables, if it is like 3 variables, you can say it like y equals intercept plus c means the intercept plus m1 x1 plus m2 x2 plus m3 x3, like that. It will be going according to the number of variables. Okay, then this best fit line will be determined. Okay, best fit line will be determined according to the gradient. That means the slope of the x1 and the slope of the x2, that means m2, and the slope of the x3, that means m3. With all of these 3 gradients and with the intercept, it will be determined what will be the best fit line. Okay, those are the things I want to explain about the linear regression model. And you have, I think you got the point. That means by using a linear regression model, if there are one variable, okay, by keeping that one variable as the independent variable, we can have a best fit line by the model, and we can predict the dependent variable. If it is like a real estate price prediction, okay, according to the size, it can predict the what we call price of the house. If there are more variables, we can go for a multiple linear regression model, and according to that, by using those gradients and the things, model will be determined by minimizing error and having a best fit line. It will be determined. It will be giving a prediction to the price, right? And I want to also explain what you have to do by learning these theoretical things. You have to paraphrase the things what you have gained here. Then only you are getting those concepts properly. Okay, write it as assignments, and you have to work as a team. Okay, by using a Zoom meeting, share the things, and I want to see how you are working. Okay, take the screenshots and upload those things to a Word document, and with the content what you are getting here, and the last page of that one, show your teamwork performance. Okay, those things also you have to add to your report, but do it as a rough report as the first way, when you are learning it as the first way. But after completing the project only, you want to complete the report. Okay, after completion is done in the project, you can deal with the report. Okay, but I want to have the proof of the things what you have done as the group discussions. You have to upload when you are discussing these things, take the screenshots of those things. Okay, right. Then now we have understood about the regression model. Then we can go for the practical. Okay, by understanding Python concepts. Okay, the next video we can see how do we implement this regression model using the Python environment. Okay, then we'll meet with the next video. Thank you.